Hi, good afternoon. Today, me, Rafael, Alejandro, and Jair Enrique are going to present the top 10 of the most important events on history of physics. First, we have laws of free fall of Galileo Galilei. Basically, this proved that all objects fall at the same time, not because of their weight, it's because of the speed of falling, which is 9.81 meters per second. He created with experiments the theory that all objects fall at the same time regardless of their weight. To prove it, he threw a wooden ball and a cannonball at the same time. Both fell at the same time, changing Aristotle's theory. Now we have law of universal gravitation. Newton deduced that the force which the two masses attract each other is proportional to the product of their masses divided by the distance that squares them away. The law implies that the closer and more massive the bodies are, the more intensely they will attract. Laws of motion. Newton's first law of motion states that in order for the motion of an object to change, a force must act upon it. This is a concept generally called inertia. Newton's second law of motion defines the relationship between acceleration, force, and mass. Newton's third law of motion states that at any time a force acts from one object to another, there is an equal force acting back on the original object. If you pull on a rope, therefore the rope is pulling back on you as well. Atomic theory. The Briton John Dalton showed that matter is made up of indivisible particles called atoms. We call this atomic theory, which is today the basis of modern chemistry and physics. It is known as the changing frequency in a wave as a result of the relative movement of the sender and receiver. This is why we hear a sound louder or lower.
And to finish, this is our bibliography, and that's it. We hope you like it, and please give us a 10. And finally, 10. The acceleration of the expansion of the universe, 1929. What Hubble and his co-authors had observed was the very expansion of the universe itself. To use a famous analogy, the galaxies are like raisins in the bread dough of the universe. As the dough rises, all of the raisins move farther apart, but they are still stuck in the same dough. The discovery enabled the calculation of the age of the universe about 13.7 billion years old. 9. Law of General Relativity, 1950. The general theory of relativity, which mainly applies to particles as they accelerate due particularly to gravitation and acts as a radical revision of Newton's theory, predicting important new results for high-speed and/or very bulky bodies. 8. Law of Special Relativity, 1905. The special theory of relativity, which essentially deals with the question of whether inertia and motion are relative or absolute, and the consequences of Einstein's conjectures that they are relative. 7. Quantum theory, 1900. In 1900, physicist Max Planck presented his quantum theory to the German Physical Society. Planck had sought to discover the reason that radiation from a glowing body changes in color from red to orange and finally to blue as its temperature rises. 6. Law of Conservation of Energy, 1847. James Prescott Joule established that energy cannot be created or destroyed. It is only capable of passing from one form of energy to another.